Right, so welcome to our discussion as we continue with question number 6. Especially if you are doing pure sciences, this is actually good for you. You need to remember all this. So it says figure 6.1 and figure 6.2 show two electronic circuit components. So you can see this component. This is basically a resistor. This is a resistor, and that one there you can see that's a capacitor. If you have learned about them, you should be able to record them. So use the color codes in table 6.1 to calculate the resistance of the fixed resistor in 6.1. So they have given you that. So I love to actually remember that by saying, bad beer, spoils our young gut, but vodka goes well. So this is just a memory aid to help you remember that. That's 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So from black, brown, all these colors, you can remember them like that. Now the way it is when it comes, let me just give you an idea. When it comes to resistor color coding, the whole idea is that they'll give you a particular color. They may give you another color, you may also be given another color, then there will be one that will go to the far end. So the first one is actually the first digit. Then the second color is representing the second digit. Then the third color is actually a multiplier. And the last one after the space there, this is what we call the tolerance of the fixed resistor. So that's what you need to remember. Now since they want us to calculate the resistance of the fixed resistor, so what I'm going to do is that I need to ask myself, what's the first color? It is red, so call there. So that's the first digit. So the first digit will be 2. Then the second color is orange. So what's the second digit? Orange is 3. Then times. The third is a multiplier. So 10 by what? So what's the third color that we have in blue? So blue is 6. So that's the multiplier. So it will be 10 raised to the power 6. And this you could have said in ohms. So that's your resistance. But in reality, we would have written this as 23 times 10 to the power 6 plus or minus. Because there's no color for the tolerance, that means it is 20% if you have learned about it, and that is going to be in ohms. So basically, you could have actually talked about this one. Obviously, another person might have said 23 mega ohms. It's okay. So 23 times 10 to the power 6 ohms, or if you want, I would have taken it to mega. So that is mega ohms. So that's the idea, and that's the way you can actually run that down. B1 says, name the electronic component in figure 6.2. Like I said, that is simply a capacitor. Please watch out for my electronic components for videos under electronics so that you can actually learn something. Subscribe to my channel if you love what we do. B2 says, state 2 uses of the components in figure 6.2. So a capacitor is simply one, we can simply say used for smoothing. Yes, so used in smoothing in power supply. So you can actually, smoothen the power supply. It's possible. Yeah, so you can actually, so that you are able to smoothen the currents of power supplies. That's what you can do. Then apart from that, a capacitor stores electric. It actually stores electric charges where it can, when you charge it, it is also able to discharge. It is able to discharge. So therefore, it stores electric charges. So that's what it does. Watch out as we come and do question number 7 together, so that we finish up this question paper together.